Keith with Cure Starts Now, but have you also met Tamara Ekus from Reflections of Grace?
We have not met, but I'm certainly familiar with you.
Okay. Well,
Nice to formally meet you.
She joins us obviously as the DIPG Collaborative. She is kind of the representative for the DIPG Collaborative here on this call. And we wanted to try to connect with you a little bit about your grant.
The way we got to this, the proposal that we came up with is by trying to come up with strategies that would counteract resistance, which is, the problem that all therapies for kids with DIPGs run into. They either have limited activity to start with, or the kids rapidly become resistant to them. And so our underlying philosophy behind this work was to try to identify mechanisms why. And so I guess that's the broad background for, how we got to this.
Well, and you talk about the NAD pathways and their role in that. Can you try to explain, what you're seeing there and why you think that that may help to get past that tumor resistance in DIPG?
Yeah, so we, as preliminary data, we went through a large number of individual agents and came up with a prioritized list of agents that actually matched fairly closely with what some other groups had identified, like Michelle Manger's group. We identified histone deacetylase inhibitors way back in 2013 or 14 as being potentially very active agents against these tumors, and also proteasome inhibitors. So histone deacetylase inhibitors interfere with the pattern of genes that are expressed. Proteasome inhibitors interfere with protein processing. So they both seemed like logical targets. There were a number of other targets that we examined as well. Ultimately, we combined agents at clinically achievable doses. And the most effective combination that we came up with was a combination of a histone deacetylase inhibitor like panobinostat and a proteasome inhibitor, initially bortezomib and more recently marizumab. Okay. So we treated DIPG tumors in culture as well as other high-grade gliomas, and we found that they responded very well, which was encouraging. But as we grew them for a period of time, we realized that a subset of those tumors were escaping and cells were growing and ultimately were completely resistant to the agent. So we did what's called RNA sequencing, looking at the patterns of genes that are expressed by the resistant tumor cells versus the original tumor cells. And we also looked at cells that had recovered from exposure to both of these agents. And a month later, looked at them in parallel. And we found that a number of targets in the NAD pathway were substantially upregulated in the resistant cells. We then looked at NAD activity in the resistant cells and found that it was dramatically upregulated in comparison. The problem that we were targeting is that a lot of our own and other people's ideas, that seemed very good, unfortunately didn't pan out as well as we all hoped. And the fundamental question we wanted to know is why. And that's what got us sort of down this pathway. And we began looking at components of the NAD pathway through the RNA sequencing that we had done. And we found that one particular protein, QPRT, which has a super long name, but basically that was dramatically upregulated by a factor of 10 compared to the naive cells in the resistant as well as the recovery cells. So the resistance not only was seen initially, but it persisted. And so once the tumors became resistant to that particular strategy, they didn't recover.
Yeah. Well, hopefully this will be the one that will have the success with it. But we always talk about trying to capitalize upon things that we've learned in the past and take it to the next step. So we're very thankful to see this. It's definitely a slightly different direction, but it's also keyed in off of what's been done before. So this is really exciting stuff to be done. Tamara, did you want to say a few things?
Well, with that in mind, and on behalf of the DIPG Collaborative and representing the Reflections of Grace Foundation, we would like to present you with $50,000 for your role of QPRT and NAD pathways in DIPG treatment resistance grant. So we're thrilled to present you with that.
Oh, well, thank you so much. We are grateful, and we certainly need the resources to keep doing the work that we're doing. So it will make a big impact. Hopefully it will translate into an impact that will be beneficial for kids with these tumors.